last year, Nike got ahead of the rest of the footwear world as the first company to release a shoe with 3D printed components. The production of the Vapor Laser Talon did not simply use 3D printing for prototyping purposes, but incorporated a 3D printed plate into the final product. This year, the company is making headlines again with their updated football cleat, the Vapor Carbon Elite, which will make its debut at Super Bowl 48. With the Vapor Laser Talon, the design team at Nike worked with Olympic sprinter Michael Johnson and his MJP NFL training center to design a shoe optimized for use in the straight line of a 40-yard dash. The Laser Talon successor, also made with the help from MJP, is meant to expand the shoe's design for use by an entire football team. The Carbon Elite therefore was needed to increase the speed and traction for linebackers, running backs, and quarterbacks regardless of their direction of movement. Like the Laser Talon, the design of the Carbon Elite was focused on the zero step of a player, the movement at which the player begins moving. The goal was to reduce the slippage that may occur during the zero step as much as possible. The head of innovation at Nike, KOHATSU, explained how the entire design process was sped up dramatically with 3D printing. Something like this would have normally taken Nike 2 or 3 years at least. They accomplished this in 6 months. Let's see how Nike accomplished this new design in this video.
Above all else, Nike exists to serve athletes. We push the limits of innovation to help athletes perform at their highest level. The journey to create the Vapor Carbon cleat for the 2014 Super Bowl began in 1996 in a very unexpected way, with one of the world's greatest athletes, Michael Johnson.
When we took that shoe that we made for his 400 meters, we said, hey, let's take everything out of that shoe and only put in the things that Michael needs to win that race. What we got out of that was not only making an athlete faster, but actually propelling us forward into the future of football. Michael Johnson told us, hey, let's focus on the zero step. Let's get that ignition off of the line and make sure that the athlete's not slipping at all.
The zero step is where we've identified certain techniques that the best use to get out of the blocks.
The Vapor Laser Talon project was specifically around designing a cleat for the 40-yard dash for athletes to run their fastest.
The stance that you put them in starts to take effect before you've ever even moved up the starting line.
When our team focused in on the zero step, we found minor slipping that was occurring at every single step, and that was our big aha moment. How that translates into product is to improve the geometry of the cleat and the plate of the shoe, and that's where 3D printing comes in. Using traditional prototyping methods, it might have taken us years to translate these learnings onto an actual cleat for the field. But with 3D printing, it could just be a matter of hours.
For the first time ever, we are able to take the learnings from 3D printing and the 40-yard dash and the Vapor Laser Talon, and we are able to inject that directly into the Vapor Carbon.
The ultimate proof that we have succeeded in helping athletes become faster is MARQUISE GOODWIN running the fastest time at the combine.
You know, they see a guy run 4.2 and everybody wants to, wear his same shoes.
So how do you translate a cleat for the 40-yard dash, which is basically a dragster, into a performance racing machine built for game day? The Vapor Carbon V-plate allows an athlete to cut better, to create more precise movements. Silver represents the pace of innovation, winning championships, and ultimately the highest honor in football, the Vince Lombardi Trophy.